Hello, good morning students. Today we are going to discuss chapter 15, probability. The reason why I started this chapter is because most of you have received a message that by the end of this month you will have a test of 25 marks and the chapters included are chapter number 1 and chapter number 15. Chapter number 1 we have already done. Chapter number 15 we have not done. So that's why I am going to chapter 15 first, and then I will complete chapter number 3 which we were already doing. So let's discuss chapter number 15 first. What you must understand here is that probability is theoretical in nature. A lot of thinking has to be done. But probability is also very common. You see, for example, you often ask yourself this question: what is the probability that it is going to rain today? Okay? People who work in the meteorological department, the weather department, they are constantly getting new data. They are gathering data about temperature, about pressure, and also about other weather phenomena. Okay? Based on temperature and weather patterns, on temperature and pressure patterns, they are able to predict whether it's going to rain or not. But that is again a probability. That is not a certainty. If they say that it is going to rain tomorrow, that means the probability that it is going to rain tomorrow is quite high. It doesn't mean that it is 100% going to rain. So we come across probability in life many times, and we have to select certain things where probability is involved. For example, if you apply for admission after 12th standard in an engineering college, what is the probability that you may get admission? The probability of you getting admission would be higher depending upon your marks. Sometimes you see you are asked about certain events that take place in your life. For example, you are going from home, you are going to school. What is the probability that a dog may bite you on the way? Well, the probability is very low, but it also depends upon the number of dogs which are near your house or near the school. So we are constantly being asked to evaluate probability or chance. Okay? And there is a mathematical way of calculating probability. So we are going to study today mathematical probability. What are the chances of certain event happening or not happening? For example, you are playing, suppose Virat Kohli and another captain of the Australian cricket team, okay, Smith, they go out to do the toss. And then Virat Kohli flicks the coin. Now what is the probability that if Steve Smith says tails, he is going to win the toss? Well, there are only two outcomes possible. The first outcome is head and the second outcome is tail. There is an equal chance of head and equal chance of tail. So there is an equal probability that Steve Smith may win or Virat Kohli may win. So both of them got a 50-50 chance, or the probability is 1 out of 2, 1 upon 2 or 0.5. So probability is something that we come across in everyday life. Now let us study it in detail a little bit. It's not a very lengthy chapter and I'll finish it in 2 or 3 videos. But just let's get started. You have also studied this probability last year in 9th standard, so it's not completely new. Probability of an event is written as, suppose an event is event E. How do you write it? P of E is equal to number of all favorable outcomes for event E upon all possible outcomes of the experiment. Now what is this experiment? The experiment is the experiment of tossing the coin. When you are tossing the coin, that is called an experiment. What happens as a result of that experiment is called a trial, or it is called an event. So supposing I want to toss a coin, that is an experiment. Let us call it E, experiment E. So what is the, if I conduct an experiment E of tossing the coin, what is the probability that I will get a head? Okay, so there are 2 possible outcomes only, either a head or a tail. So number of all possible outcomes will be 2. But if I want a head, then there is only one possibility of getting a head. Therefore the probability will be 1 upon 2 or 0.5. So whenever you solve problems on probability, remember you must write this always. Always write this. Probability of event E is number of all favorable outcomes for event E upon all possible outcomes of the experiment. Always write this every time. Alright. Now the probability of an event E can lie between 0 and 1, including 0 and 1. But probability cannot be greater than 1. Probability cannot be negative. You can't say minus 0.5. Probability will never be negative. Or probability cannot be greater than 1. It cannot be 1.5. Probability can lie between 0 and 1 only, including 0, including 1. That means the maximum possibility of a probability is 1 and the minimum probability is 0. If the probability is 0, it's called an impossible event. If the probability is 1, it is called a sure event or a certain event. For example, the sun is going to rise in the east tomorrow. Now that is absolutely certain, absolutely 100% sure that the sun is going to rise in the east tomorrow. That's a certain event or a sure event. The probability of event would be equal to 1. But what is the probability the sun is going to rise in the west tomorrow? We know that sun will never rise in the west tomorrow. Okay, so that's an impossible event. So if it's an impossible event, the probability is 0. So once again, probability always lies between 0 and 1, including 0, including 1. Probability cannot be negative. Probability cannot be greater than 1. Probability of a certain event or a sure event is always 1. Example, the probability of the sun rising in the east tomorrow. Probability of this event is equal to 1. Probability of the impossible event is 0. Example, the probability that the sun will rise in the west tomorrow, that probability is equal to 0 because it's an impossible event. Alright. Probability of a complementary event. Now what's a complementary event? Supposing I toss a coin, okay, and I choose head. What is the probability of getting head? Well, 1 upon 2 or 0.5. But what is the probability of not getting head? Head and not getting head, they are called complementary. Getting 1 and not getting 1. Passing and not passing, they are called complementary events. Rising in the east and not rising in the east, they are called complementary events. Okay, so for a probability of an event A complement, you see there is a dash on top. This is called A complement. Probability of complementary event. P of A is an event, P of A complementary is called the event not of A. Okay, supposing I say head, then not getting a head is called the complementary event. Okay, complement of event A, and the sum of the probabilities of the event and its complement is always equal to 1. The sum of the probability of an event and its complement is always equal to 1. Alright, here look at this one now. The sum of all elementary events of an experiment is always 1. See, supposing you take a die, okay, or a dice, a balanced dice, for which we play Ludo and snake and ladders, we use those, okay, and this is called a dice, you see, this way. A dice, or sometimes it is called a die, and it has got numbers from 1, 2, 3, 4, 5 and 6. Okay, it has got 6 numbers on the balanced dice. Now, what is if you roll the dice once, what is the probability that you will get 4 on top? Well, the probability of getting 4 on top is 1 out of 6. Out of 6 possible events. In total there are 6 possible events. But the favorable event is only 1, and that is 4. And therefore it is 1 upon 6. The probability of getting, if you roll a balanced dice once, the probability of getting 4 on top is 1 out of 6. Similarly, the probability of getting 2 is also 1 upon 6. Okay? So each event, you see, each one would be 1 upon 6, plus 1 upon 6, plus 1 upon 6, plus 1 upon 6, plus 1 upon 6, and so on. 1, 2, 3, 4, 5, and 6. And this would be equal to 6 upon 6, and that would be equal to 1. So these are called elementary events. These are called all elementary events. So this is, for example, P of A. This is P of B. This is P of C, P of D, and P of E. And that is equal to 1. So again, the sum of all elementary events of an experiment is always equal to 1. P of A plus P of B plus P of C plus P of D, or even P of E as in this case, that is always equal to 1. So in this case, what was the experiment? The experiment was rolling the dice. Now what were the elementary events? Elementary events, P of A getting 1 on top, P of B elementary event getting 2 on top, P of C elementary event getting 3 on top. There are 6 elementary events. The probability of all of them together will always be equal to 1. Alright? Now, Let us do some experiments, rather some similar kind of experiments, or what we call examples. Let's do some examples, okay, based on probability. I've done 3 examples here just now. Let's understand and discuss each one. See, a balanced coin is tossed twice. A balanced coin means it is a true coin, okay, it is not unbiased, it is a fair coin. One side has got head, the other side has got tail. A balanced coin is tossed twice, once and 2 times, okay. What is the probability of getting 2 heads? So if I take one coin, head or tail, take the other one, head or tail, okay. Now it is tossed twice, once, twice, 2 times. So all possible events are what? You may get head on both the coins, both the times. The first time also head, the second time also head. Or the first time you may get head, the second time you may get tail. Or on the first coin you may get tail, and the second try you may get head. Or on both you may get tails. There are only 4 possible events. There are no 5 events. Head head, head tail, tail head, and tail tail. So out of this, what do we want? We want 2 heads. 2 heads is only 1. So suppose P of A is the event of what? Getting 2 heads. Probability of event A. What is the probability? Probability of getting 2 heads. Number of all favorable outcomes upon all possible outcomes. Favorable outcome only 1. Out of total outcomes 4. So 1 upon 4 or 0.25. Probability always lies between 0 and 1. So 0.25. Alright? Look at this one. Suppose you take 3 coins, 1, 2 and 3, and toss them simultaneously. Simultaneously means at the same time. All of them go up and come down. Okay? What is the probability of getting at least 2 heads? Okay, this word at least 2 heads is important. What is the meaning of at least 2 heads? Minimum 2 heads. You can get more than 2 heads, but not less than 2 heads. Alright, what is the probability? Let's see now. All possible events. Now look at these possible events. All 3 may be head, or all 3 may be tails. In between 2 heads and a tail. Now shift the tail. Head, head, tail, head, tail, head, tail, head, head. And then 2 tails. Head, tail, 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 head, tail, 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 head. And all 3 tails. So there are 8 possible events. Here there were only 4 possible events. Here there are 8 possible events. So suppose P of A is probability of getting at least 2 heads. Minimum 2 heads. You can get 3 heads, but not less than 2 heads. So 1, 2, 3 and 4. Here in this case, in this 4, there is only 1 head, but we want at least 2 heads. So 1, 2, 3 and 4. So favorable events are 4 and all possible events are 8. 4 upon 8, 1 upon 2 or 0.5. Let us take another one. Okay. A box contains 8 red balls, 2 pink balls, 4 white balls and 6 green balls. One ball is selected from that box or it is picked out randomly without looking. You just put one ball out of the box. If one ball is drawn from the box at random, then what is the probability that that ball which we have drawn from the box will be a white ball? Now look at it. Number of all possible events. How many events will be there? There are how many balls? 8 plus 2 plus 4 plus 6. That is 20 events or 20 balls. Okay? And number of all possible events, the number of white balls, because we want the ball to be white. So number of white balls is 4. There are 4 white balls. So P of A, probability of event A. What is the probability of event? Probability of selecting a white ball. That is equal to number of favorable outcomes upon all possible outcomes. That is 4 upon 20. There are 20 outcomes totally, 4 favorable outcomes. Or 1 upon 5 or 0.2, or you can write 0.20 to 2 decimal places. Okay? 0.20 to 2 decimal places. Now, obviously, you can see this kind of a possibility. These are not difficult ones. Now, let's do a few more of this kind. Okay? Make sure you study this, write it in your notebook, and when you are writing it, write it slowly. You can pause the screen also. Alright, let's do some more of these. That was number 3. Now let's do 4th one. Okay. Now suppose a balanced die is rolled twice. What is the probability of getting the same number on both die? Okay, now let us see what happens. Supposing you are rolling the dice twice, okay, so therefore all possible outcomes are, now what are the possible outcomes? First of all, 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. First die 1, 1, 1, the second die 1, 2, 3, 4, 5, 6. Now on the second dice, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Okay, and similarly 3, 1, 3, 2, 4, 1, 5, 1, 6, 1. Okay, and here 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 2, 4, 3, 4, 4, 4, 5, and number 6. Similarly, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Alright, now the question arises that what is the probability, how many events? 36. 6, 6, 6, 6, 6 into 6. That is equal to 6 into 6, 36 events. Okay, 36 events. Now, probability P of A, probability of getting the same number on both die, all favorable outcomes, upon all possible outcomes, alright. So now let's see, all possible outcomes is of course 36. Alright, favorable outcomes, you want same number, okay, same number on both the dice. So if you want the same number on both the dice, 1, 2, 3, 4, 5, and 6. Same number on both the dice, and therefore there are 6 such events. 6, 6 are 36, 0 point, okay, 1 upon 6, 0.40, 6 are 36, 0.1666, it will go on repeating, okay, and therefore 0.17 up to 2 decimal places, approximately up to 2 decimal places, 0.17. Now you can see these are not difficult problems, but you have to be sure about this, otherwise it can go wrong. And also problems involving balanced dice, you must learn to write this. If you don't learn to write this, then it's difficult to. Any problem involving balanced dice, this list is necessary, so that you can actually check from here and get all favorable outcomes. Alright, let's try another one. Okay, a card is selected from a pack of cards at random. Okay, what will be the probability that the selected card is a queen is number one, a queen a face card, number three, a number card, and number four, an ace of spade. Alright, now for this question you got to know how many cards are there. Okay, there are 52 cards in total. Okay, out of these 52 cards we have got 4 suits. Okay, they are called 4 suits of cards. 4 suits of cards. Okay, these 4 suits are, 2 are black in color, these 2 are black, and these 2 are red in color. Okay, and face cards. Face cards, king, queen and jack. Right, king, queen, jack. That is 3 into 4, that is 12 cards. Non-face cards. Non-face cards are 52 minus 12, that is 40 cards. Okay, now the question is the first one. Probability of event A. What is the probability? Getting a queen. Now what is the probability of getting a queen? There are how many queens? 4 queens. So 4 out of 52. That is equal to 1 upon 13. Okay? There is no need to write decimal point. Alright. Then the second one. P of P. Probability of getting a face card. Getting a face card. Now there are how many face cards? You can see king, queen and red. There are totally 12 face cards. So 12 out of 52, which is equal to 3 upon 30. And third one, P of C. P of C getting a number card. Getting a number card. Number cards are 40 cards. Okay, so this will be equal to 4 tens are 40, 4 13s are 10 upon 30. Then P of D getting an ace of spade. Getting an ace of spade. Okay, 4 ace, there are 4 aces, but spade का एक ही है, only 1. So 1 upon 52. Alright. When it is possible to convert into decimal, convert into decimal. If it is not possible to convert into decimal, don't worry about. You can keep it as 1 upon 52 or 10 upon 30, 3 upon 30. Alright, these are some of the examples and probability. All your examples and all your exercises will be similar to this. Every time you have to write in the same way. Alright, now I am going to do the exercises tomorrow. So all of you just make sure that you watch today's video. Write whatever I have done today, write it in your notebook. Okay, give the heading probability, chapter number 15, probability. Whatever you have seen today on the board, write it down, keep it ready for tomorrow. Tomorrow I will send you at least half the exercise. I will do it tomorrow, so you can get started. This is a short chapter, easy chapter and a scoring chapter. Okay, have a nice day.